Hi everyone, this is the second video for HEC-RAS simulation and flood inundation mapping. In this video, I will do the steady-state flow simulation. For doing that, I will input the flow data required to run the model and set up and downstream boundary conditions as a first job. So very firstly, you need to go to menu for edit and click steady flow data. Then you can find a new window for steady flow data. On here, you need to save flow file first. So click file and click save flow data as, and then you can find this new box for inserting title of the flow data. So you need to go to the same directory folder. In my case, I assigned my working directory C under temp under HEC-RAS. Okay, so in here I will give my title for flow data same title of the 1D model. Then click OK. After that, we need to check the working directory. So here you can find the new file is generated with different extension. This is actually the flow data for this project of the HEC-RAS model. And then you know all the required previous developed data in here. After that, we will use three different flow data sets, so you need to change this would be as 3, and then apply data. You can find this newly developed table. So I will use three different scenarios for this steady state flow simulation. So I developed these three different table for the Tippecanoe tributary river and Wabashi up and lower river systems. Okay, so this is the very first one required to insert the Tippecanoe rivers the flow condition. I will insert in here this one and this one. Again, I will use three different scenarios for some different flow conditions. And then Wabashi River, I will insert and then lastly, the low Wabashi River is the summation of the upstream flow. So I will provide in this table with this number and this number. And okay, I already got all the flow data for simulation for this kind of the steady state condition HEC-RAS model, and then just click apply data. And then you need to go to this reach boundary conditions button to click, and then you can have this new box for the inserting all the required boundary condition for the steady flow. So as you know, we have two upstream and just one downstream rivers. Okay, so in this upstream you need to insert these kind of options. Okay, but in this case I will just use critical depths for Tippecanoe tributary upstream condition, and also this Wabashi upper stream condition I will also use critical depths. So if you are available, please find the HEC-RAS manual for the details for seeing the details of the what these options means. Okay, and then for the downstream lever, we will use normal depths. In this case, we need to enter downstream slope for normal depth computation for leach. So in here, I will insert slope as 0.002. Okay, and then we made all the required boundary conditions on here. Again, you can easily find the HEC-RAS manual what these kind of options means. In this tutorial, I will not give a theory part, but this kind of actual tutorial for developing and simulation of the HEC-RAS model, so you can easily find that kind of the basics from the HEC-RAS manual. Okay, we are ready to OK. Just click OK. So we've done all the required static flow data. So you need to close this window, and then you can also use this icon to open the static flow data editor. Okay, like this one. Then you need to run the model, so click this run menu and this static flow analysis. Then you can find this new window, new box for that. And then before proceed the simulation things, we need to make a new plan. So the same folder, our working directory, you need to make a new plan. Title, just the same 1D model. Then just click OK. In that case, you need to answer what is the show plan identifier. So I will just use static flow. Static flow for that. And then you can find this short ID on here, and this the static flow analysis. We use this geometry file we developed on here, geometry, and then flow data file also on here, steady state, and now we developed this kind of plan. So now we are ready to run this model, but flow regime we just use this supercritical condition we just use. So this subcritical, supercritical, and mixed one also you can find in the HEC-RAS manual. After that, we are ready to compute all the required flow simulation with the HEC-RAS. So just press this compute button. And then you can find this kind of HEC-RAS computation. So now we are all done with this simulation work. So you can find the status of the simulation. So maybe this depends on the computer, the performance, but not much required the minutes on the minutes, because this kind of the simulation flow steady state flow simulation is very simple, so you can get very quickly the result. Okay, and then you need to close this computation status box, and also you can close this static flow analysis the box as well. Again, you can use this icon for the static flow simulation. like this one, you can also open with the icon. So in this point, we need to check our working directory because some data is changed, not changed, the created some the other data. Lastly, we developed this flow data, geometry data, and this projection data. But in here, you can find the different data set, different data files with these different options. This would be kind of a plan for the flow simulation. And also you can find some the backup files. You can delete it if you don't want to. This kind of backup file. So from the only the projection file like this one project file, we developed very different model files. So also you can see in here we named all the same 1D model for the project file and geometry file and static flow state option. And this plan, I just used all the same the 1D model, the title, and then you can find all the associated file with this working directory. Okay. So we've done all the required HEC-RAS model creating and development and run the model. Now the remaining thing would be the how to see the result. So for the next part 3 video, I will provide two options to see the model simulation results with this RAS main platform as well as using the RAS mapper. As you know, this recent 5.0 version of HEC-RAS developed a new RAS map tool. So we will use it again to see the modeling result for the next video. This ends the second video for HEC-RAS simulation and flood inundation mapping. Thank you for watching.